So next we'll solve the question, find the common area between the curves R is equal to 3a by 2 and R equals to a into 1 plus cos theta. Right. So when we look at this particular question, it's very clear that the given curves are polar curves because we have r and theta, right? So we have to apply the rules and or the formulae associated with the uh, polar curves to solve this problem. We need to calculate some area. That's the first thing. Now, if you remember the basics, area in case of a polar curve can be calculated by doing a double integration. First could be with respect to theta, second one maybe with respect to r. What is the range of r? Limit for r. What is the range of theta or limits for theta? You need to find out. Then you need to integrate r dr into d theta. This is the very fundamental equation that we will be using, okay, to calculate the area in case of any polar curve. Okay, that's the first thing. All right, then so irrespective of the problem, whenever a question comes to find some area related to the polar curves, I should apply this. That's the point number one to remember. Okay, now let's come to the specific question. Now they're asking the area, common area between something, right? There are two different curves given, right? We have to know what kind of curves are they. Only when we know them we can plot and we can analyze. All right, so let's look at this. So r is equal to 3a by 2. It's a constant. R is nothing but we know that r is a radius vector. So radius equal to 3a by 2. A can be anything. Okay, if this is the case, then I know that radius is constant means it has to be a circle. So what they are asking here is, right, they are asking us to plot, right, the circle. That's the first one. All right, so let's try to draw this. Okay, fine. This is the x and y coordinate axis. Anyway, we are using the x and y axis just for notation purpose. Anyway, it's not being used in this problem because the whole problem is in terms of polar coordinates. All right, so first write the required graph. Okay, so let me write the circle first. So let's say, okay, so let me say that this is the required circle. Let's say so. Okay, it's fine. So this is the circle. Let's assume that the radius is 3a by 2 indicates that what are the coordinates. Let's write the coordinate. So the coordinate of this point, right, the point where it touches the x-axis, this should be as per this x varies. So this is 3a comma 0 because no height. So this point is that. Now if you want to write the coordinate of this point, so length is from the origin, this is 0 comma 0, the length is 3a but it is along y-axis, so this is 0 comma 3a, right? Similarly, let's write the other coordinate of this point, that is minus 3a comma 0, and the coordinate of this point should be 0 comma minus of 3a. All right, so we understood this is the first curve. Okay, now let's go to the second curve, right? The second curve is also a very standard curve, so let me write that. So it actually begins at 0. So okay, let me use this color. It actually begins here. So if this is 3a, sorry, it's not 3a, I think it should be 3a by 2. Sorry, my mistake, I'll just correct. So this is 3a by 2 everywhere, 3a by 2, 3a by 2, and so on. Okay, so this is also 3a by 2, this is 3a by 2 as well. In the sense it's 3 by 2, which is 1.5a. So which means the a should come somewhere over here. So let me assume that this is a, sorry, this is a, and let me also assume that this is the other a, minus a on the other side. So why we need this? Because we need a point called 2a. We need a 2a over here. So let me assume that this is a 2a. Okay, say this is 2a. Now the importance of the second curve, r equal to a plus a into 1 plus cos theta, is this. So that is this curve. Okay, and it goes till 2a. This goes till 2a, right? So this is the second curve. So this coordinate is 0 comma a. This coordinate is 2a comma 0. This coordinate is 0 comma minus a, and as usual this will be the origin. Okay, now so what they have asked is find the common area, right? What will be the common area? See, the one which I am marking now is what they are asking us to find. It's only this area. Okay, fine. Now I need, in this area, within this area, I need to apply this integral. Okay, so now things become more clear now, right? The r is actually varying in two different fashions, right? What do you mean by two different fashions? You can see here on this circle, r is equal to a constant. That's the first thing which we want to consider. And the second r is nothing but, see, after this point my curve is going to tend in this direction. See, it's in this direction, it's on this line and on this line here, correct? So I see that r changes drastically after a particular point where both the curves meet. So for example, I need to understand what is this point. See, there is a point at which both of them meet, correct? This is the point. Okay, I'll change the color just to make sure that I understand that, and I'll actually uh, mm, connect that from the origin. So if I connect from here to that point, right, the particular point is actually marked by using a specific angle, that is theta, with respect to the origin x-axis. So this theta I need to identify at this particular point, right? This is the, okay, I'll write it in a different way. So at that point, right, uh, let me mark it like the green color. So we understand that at this particular point, right, this is the point of contact. We have a point of contact. At that point of contact, I am supposed to find out a specific value of theta. Okay, right. Now let's proceed. So how to find that? It's a point of intersection or point of contact. So at the given point of intersection, right, we can equate both the curves, correct? Because that particular point of contact or point of intersection lies on both the curves. Because of that, I can write like this now. So as the point of intersection lies on both curves, both the curves, I can equate them, right? So you can equate r is equal to, first function says that r is equal to 3 times a by 2, and the second function says r is equal to a into 1 plus cos theta. So as we know that, right, we can equate them all together. So how can you write this? So this is equal to, they have to be equal. So this implies now 3a by 2, this is r. This r is also equal to a into 1 plus cos theta, right? So I need to find a theta, right? So which means I need to, right, keep tracing for the theta itself, right? So what I do, I can see the a getting cancelled over here, right? So this implies the cos theta is 3 by 2 minus 1, because this 1 goes to the other side. So 3 by 2 minus 1 will be 3 minus 2 by 2. So 3 minus 2 is 1. So this is 1 by 2. So cos theta is half, which implies now theta will be equal to, this is cos inverse of half. So that is 60 degrees, but we prefer writing in the radians. So this will be pi by 3 radians. All right. That is our first step. Now with respect to the given diagram, now I understood, right, what is the specific value of theta, for which, right, at which, at that theta, my curve is going to my two curves are going to meet. Okay, right. So now I understood the range, in the sense when theta is actually 0 degree here, 0 degree to 60 degree, my curve will be r is equal to, it's a circle, r is equal to 3a by 2. But starting from 60 till this becomes 180 degrees, right, the curve will be the other one, that is a into 1 plus cos theta. So that if you do this change, that is starting from 0 to 180, I get the required area which is above x-axis, right? But I don't want to go for the same integration once again. What I do, I simply calculate the area, because it is symmetric about x-axis, right? Whatever area you get from 0 to 180 degrees or 0 to pi, just multiply that by 2. So you get 180 to 360 also get included in that. So totally I need to do the theta variation from 0 to 360 degrees or 0 to 2 pi. But since this particular region or area which they have asked is symmetric, okay, since it is symmetric, I can simply, right, do the integration from 0 to 180 or 0 to pi and multiply the answer by 2. All right, this we come to know only by looking at the given problem. This may not be the case in some other problem, right, where you might have to do the complete integration possible. But in this case, it's very clear that I don't have to do the integration twice. Okay, so I got this theta is equal to pi by 3, which is 60 degrees. So now I'll write the required integration, so, area. Okay, so therefore the required, so, second. So required common area is calculated like this. So this is equal to, right? Let's call this as A. The area A is equal to, we know that it is a double integration. So we wrote theta value on the outside. So I know that theta varying from 0 to 2 pi. Total area I need to calculate into R varies, right? Right. So what is the range of R? R will also vary from different section. I'll simply write the R here. So this is R dr d theta. But let's expand this now. So we apply what we studied. So we saw from the given diagram that it's symmetric. So I can write 2 times. 2 times. All right. So 2 times I have first integral, because it's not the same curve, there are two curves. First curve is actually from theta is equal to 0 to pi by 3, and in this case, right, what is the range of R? Let's go back to the diagram to check. When theta is 0 to pi by 3, so when theta is 0 to pi by 3, say consider this line. Okay, so I'll change the color, to black. From the origin I connect a line here. So this is what I'm talking about. When any theta which is between 0 to 60 degree, say this black color line which I just have drawn now, right? What is the minimum length of that line? That could be 0. What is the maximum? That is the radius of the circle, correct? So R varies from, let's write that now. So this is R is equal to 0 at the origin, and on the circumference of the circle this will be 3a by 2. So see the range, theta is 0 to pi by 3, R is 0 to 3a by 2. Whenever this is the case, I need to write R dr into d theta. Okay, so R dr d theta. This is the first equation. Plus, I have another integral coming up. That is, now you see the theta varies from where to where? Theta varies from pi by 3 till pi. Okay, why only till pi? It's same as, right, I'm doing only till pi. I'm not going till 2 pi, because 0 to pi is same as pi to 2 pi. So that's why I multiply by a 2 at the beginning. So it is totally, you can see I start from, right, I actually start from 0 and my ultimate thing is pi. So 0 to pi you calculate, multiply that by 2 to get the total answer, that is 0 to 2 pi. Okay, so this is the basic idea, right, that we are going to apply in almost many problems. Almost every problem related to the calculation of area will be somewhat like this. Okay, let's proceed. So 0 to pi, and in between this, so what is the range of R? R will now, I'll go back and show you the diagram. Now you see, any angle you consider which is more than 60, say this line. Okay, say this line, what is the minimum? Minimum will be 0, but the maximum is on this curve, right? Red color curve. Equation of the red colored curve is R is equal to a into 1 plus cos theta. So my maximum value of R will be simply a into 1 plus cos theta. That's all. Are you okay? So let's apply that. So this means, again, R varies from 0 to a into 1 plus cos theta, right? Once again, R dr d theta. So I need to solve these two equations now. So first we need to simplify the individual equations, then only I can substitute. Okay, but before I go for a simplification, I need to make another substitution here. So this is equal to 2 times integral C. Theta is equal to 0 to pi by 3, and R is equal to 0 to 3a by 2, right? During this region, what is R? R is, I just have to look at what is the value of R, right? In that case, the R is defined as, I need to perform R dr into d theta, right? I can simply perform the value of R as it is given, right? R is nothing but, this is 3a by 2. R is fixed. R is equal to 3a by 2, right? 3a by 2 dr, this is dr into d theta. This is the first thing. Plus, I also have to do another calculation, that is theta is equal to pi by 3 till pi, and once again r is equal to 0 into a into 1 plus cos theta, right? Within this range, I have to do once again r dr into d theta, right? But I know something. Let me substitute. I don't want to write this as it is. Let's substitute. But r value in this range is already given. That is nothing but a into 1 plus cos theta. Okay, this is what is given, right? R is this into dr into d theta. Okay, now let's proceed. So let me call this particular equation as equation number 1. So this is, when you have the answer, you can substitute here to get A. Okay, but let us call this equation, right? Let's solve, because there are two integrals, we have to solve using different methods mostly. So what we do, we split the integrals, right? So we'll write, let integral I1 is nothing but the first part, that is integral theta is equal to 0 to pi by 3, and this is r is equal to 0 to 3a by 2, right? Do the integration, that is there is a 3a by 2 which is a constant into this is dr into d theta. Okay, so let's do the integration. So keep the first integral as it is, theta is equal to 0 to pi by 3, write the constant, that is 3a by 2 outside, into there is dr integration is r, which will be varied from 0 to 3a by 2, okay, into d theta, because r has been taken care of. So this is 3a by 2, right? Integral theta is 0 to pi by 3. So substitution of r will be like this, right? So this is when 3a by 2, it is 3a by 2. When 0, it is 0, right? Into d theta. So I know that this whole term becomes 3 into 3. I can further write it in this way. So 3 into 3 is 9a square divided by 4 times. Okay, so we are doing the integration. So we take the 3a by 2, 3a by 2, which is outside, 9a square by 4, and perform the integration. Integration of d theta is theta. You need to substitute from 0 to pi by 3. Okay, so this means it is 9a square by 4 into, this is pi by 3 minus 0. So 0 has no value, so this cancels with this as 3. So my answer to the first part becomes equal to pi into, this is 3 pi into a squared divided by 4. Okay, so the first half I'm going to get this answer itself. Okay, right, let's hold on to this. This is what is I call as equation number 2, and now I'll write the next equation. That equation comes from the second half, that is theta is pi by 3 to pi and r is 0 to a into 1 plus cos theta. The second term I'm going to write. Okay, so that is, let I2 is equal to, now theta varies from where to where, it's pi by 3 till pi, and r varies from 0 to a into 1 plus cos theta, right? This is the range of r, and I need to write r in this case because r is equal to, r is given by a into 1 plus cos theta. Okay, so that's my range of r. This is r into dr into d theta. So we need to do the integration like this. Okay, so corresponding to this, let's start with the integration. Keep the a outside because the whole thing will look like a constant for you. A will go out. So theta varying from pi by 3, this is pi by 3 till pi, the 1 plus cos theta remains here, 1 plus cos theta. So integration of dr is r, and the limit is 0 to a into 1 plus cos theta. Okay, so dr is done, you write only d theta. So in the next step, this is equal to a into integral. Now see, theta varies from pi by 3 till pi. The 1 plus cos theta is here. Substitute r. First r becomes a into 1 plus cos theta. Okay, this is the term, right? Minus 0, right? Into d theta. Okay, now in the next case, so this is a into, so you can see that a square, a comes out, a into a square, integral pi by 3 to pi. I need to substitute this one, 1 plus cos theta into 1 plus cos theta. I can write 1 plus cos theta the whole square, all right, into d theta. So now I don't have a direct substitution technique to solve this integral. I have to expand. So what I do, I write a square, this is pi by 3 till pi, expand the term 1 square plus the second term, that is cos square theta, plus, right, this is 2 into cos theta, 1 plus cos square theta plus 2 cos theta. This I can integrate there, that's why this is this. Now in this I have 3 different integrals to perform. So I understand that the 3 different integrals, I can do it in this way. Anyway, I'll do it in a single step, but I understand that there is one which is one integral. Cos square theta is the second integral. 2 cos theta will be the third integral. All right. Okay. Now what I do, I make a substitution before I do the integration. So pi by 3 to pi. So 1, what is cos square theta? Cos square theta substitution is 1 plus cos 2 theta whole divided by 2 plus 2 times the cos theta into d theta. Okay, so once we have this value available, now we can write a square right? Now I do the integration. Integration of 1 is theta, plus integration of 1 by 2 is 1 by 2 theta, plus there is a half into cos 2 theta, right? What is the integration of cos 2 theta? It is sine 2 theta divided by 2. Okay, plus the next one, 2 cos theta will simply become 2 into sine theta. So substitution should happen from pi by 3 till pi. So a square is a constant which I write outside. So theta plus 1 by 2 theta is 3 by 2 theta. So I have to write 3 by 2 times. So first number is pi, and when you substitute pi by 3, this is minus pi by 3. That is the substitution for the first part. Okay, then plus, right, there is a 1 by 4 outside. I just have to substitute sine of 2 pi minus sine of 2 pi by 3. Okay, sine 2 theta. So sine 2 theta, once theta becomes pi, another times this becomes pi by 3. So since there is a 2 already, it is 2 pi by 3. Plus next term is 2 into sine of pi minus sine of pi by 3. Okay, we substituted the values. After this, right, now we just have to simplify this. So this is a square into, so this is pi minus pi by 3 is 2 pi by 3, right? So 2 pi, this is 3 by 2 times, this is 2 pi by 3. So this cancels and you are left with a pi in the first term, plus 1 by 4 times sine 2 pi is 0. Okay, and the sine of 2 pi by 3, 2 pi by 3 is actually 120. Okay, so 120, I need to calculate sine of 120, right, which is root 3 by 2. So this minus root 3 by 2. Okay, and plus 2 times, see, this is sine pi is 0, minus sine pi by 3, sine 60. Sine 60 is yeah, sine 60 is also root 3 by 2, correct? Correct. Right, so I write this is root 3 by 2. Okay, now let's go ahead. So this is a square into, first term is pi, next minus this is root 3 by 8, then this term is simply minus root 3, because 2 will cancel, minus root 3. So let me simplify the term which is present inside this to get a number. So we have initially a pi minus, the first term is root of 3 by 8, and the next number is minus root 3. So this answer is 1.193 a square. So this is the second term, I2, which I call it as 3. Now you can see I need to substitute these two values, that is equation 2 and equation 3. I should put back in 1. Okay, what I do, I'll simplify equation 1 as well, so that this becomes easy for me. So this implies I have to simplify this 3 pi by 4. Okay, so this is 3 pi by 4. That becomes 2.356 times a square is this answer. Okay, so let's substitute 2 and 3 in equation number 1. Okay, so therefore, so equation 2 and equation 3, in first equation I get the answer a is equal to 2 times let's look at what was the equation 1. 2.356 a square. This is 2.356 a square plus just now we got 1.193 a square. So this means I just have to add 2.356 plus 1.193, that is 3.54. Okay, so this is equal to 2 times 3.549 a square, right? So I need to multiply this by 2 now because there is a 2 outside. So that becomes 7.098 into a square is the final answer, and this is the required total area.